Thank you very much all for joining us. And I know it's a little awkward silence just at the start while waiting, but we really appreciate your time for this event. This is Understanding 2020 Memory Triggers with Dr. Adamos, a senior lecturer in psychology at the Melbourne School of Psychological Sciences. We're glad to have you here, and also he's got his cats joining us, which is really cool. Before we begin, and for those attending today, we'd like to acknowledge the traditional owners of the land we're on today, the Wurundjeri people of the Kulin Nation, as well as the traditional owners of the land you yourselves are situated on, and acknowledge that Indigenous Australians have been custodians of the lands and waterways of Australia for thousands of years. We pay our respects to their elders, past, present, and emerging. And we thank you very much for being here. My name's Gary Williams, and I'm the creative producer of innovation at Melbourne Connect. Part of the University of Melbourne delivering this event for you today. So this event series, Understanding 2020, is a collaboration between Melbourne Connect and the Melbourne School of Psychological Sciences. And these fortnightly online events are predominantly designed to delve into a range of topics, crossing over, as I mentioned just before, a difference between social and clinical psychology, focus on really current and relevant topics with evidence-based research and leading psychologists appearing to drive these discussions. Before we dive into the presentation today with Adam, I'll give you a little introduction and some context as to what Melbourne Connect is. Let me just share my screen here. There we are. There we go. So this is, and I must say, if you're having trouble seeing the screen, do scroll to the top of your window to see the view options and select Fit to Window, and that'll be able to show you how it is in perfect showing. So what is Melbourne Connect? Well, Melbourne Connect is a forthcoming innovation precinct launching at the start of 2021 on the corner of Swanston and Grattan Street. It'll be a connected innovation ecosystem which will co-locate university researchers, industry partners, emerging talent, inventors and more. We have some relevance today in regards to, Adam will speak about the Complex Human Data Hub, which will have a place in Melbourne Connect precincts, but also located in the precinct will be the Melbourne School of Engineering, Science Gallery Melbourne, Centre for AI and Digital Ethics, Melbourne Accelerator Program. We'll have co-working, a Fab Lab makerspace and much more, and of course event spaces such as these pictured. We also have public space areas such as the Oculus, which is pictured here, and Melbourne Connect will open at the beginning of 2021 at a time which will soon to be announced. And yes, we'll be running events exactly such as these, designed to deliver a broad cross-section of content, and I'm really excited to deliver this one today for you. So memory triggers, this is what we're discussing today, and I'm really excited to have Dr. Adamos, who's participating in the discussion. He's a senior lecturer in psychology at the Melbourne School of Psychological Sciences. And myself, I'm the creative producer of innovation for Melbourne Connect, as I mentioned before. So memory triggers, what triggers a rush of memories when you find yourself in nostalgic environments or your senses cause you to remember situations? And what context prompts us to remember these instances that are seemingly long forgotten? I'm really excited to dive into this one. It's and I think quite a number of you are too. Just a tiny bit of background on Adam. I'll do you the service of doing it for you before you leap into your prezo. Adam studies human memory from an empirical and computational modelling perspective, and he presents on what triggers our memories and our current theoretical understanding of it. He's part of the Melbourne Computational Memory Lab, and as I mentioned before, a member of the Complex Human Data Hub. His specialty is the computational modelling of memory, which uses a combination of experimentation and model fitting. He also has been interested in combining models of memory retrieval with more detailed specifications of both decision-making and representations. I'm going to put some links to his research, some articles, and also his website in the chat function. That includes a recent article published in The Conversation, which is a fantastic resource. So I'm going to stop the sharing right there. Adam, thank you very much for joining. I've sort of spoken ad nauseum, but really appreciate you and your cats for being here today. How's everything going?
Yeah, good. Hopefully my cats don't interrupt too much during the course of
No, No, we like it. We like it. It's yeah, it's a nice byproduct of running the events, and obviously we embrace the scenarios of running events from home. I've had deliveries rock up while in the midst of Q&A, so it's fair game, it seems. So look, if do you need anything else before we kick in?
Should I just share my screen now, or?
Yeah, well, I'll just give a tiny bit of housekeeping just first. We're going to 1:30 p.m. today. This session's being recorded for anyone who would like to observe it after or of course, share it out. And lastly, if you have questions, please do put them in the Q&A function at the bottom or the chat function. Either is perfectly fine. Adam's going to do probably a 20-minute presentation now. And then we'll launch into some curated questions. So I'll post some, but also feel free to put some through both throughout the presentation or after he's finished. So without further ado, Adam, take it away. And I'm sitting in the background in case you need anything.
Cool. Right. How's my screen showing up?
Sure is.
Cool. Great. Excellent.
Great.
So my name is Adam Ost. As Gary mentioned, I study primarily computational modeling. And the principal question I'm usually addressing in my work is really just how does learning and memory work? What are the mechanisms involved? How does it operate? That sort of thing. This is a different question than usually what people ask me when I tell people I'm a memory researcher. Well, the first question I always get asked is like, why is my memory so bad? Which is kind of a hilarious question because it's a question everybody seems to have, and it can't be true for everyone. It's like the opposite of the Lake Wobegon effect. Not everybody can be below average. But people are very curious as to why they can remember some things but not others. Like, why do I remember some things but am unable to remember others? Why is my memory getting worse? What can I do to improve my memory? These are the kinds of questions that people usually ask me. So these are the two questions I'm going to be covering, and they're highly related questions. You can really only understand the second question if you understand a little bit of how something operates. Just as any kind of machine, you need to know a little bit about how it operates to understand why it sometimes succeeds and sometimes fails. Now, people have actually been thinking about how learning and memory work for a very long time. Some of the earliest theories of memory, learning and memory operate in terms of just associations. Meaning that if you see two things that occur at the same time or occur nearby in time, such as A and B, they become associated together. And these can be anything. This is why I use A and B here as abstractions, is, substitute what you will. It could be two objects that, occur at the same time. It could be a sight and a sound. For instance, the sound of a trumpet along with the appearance of it make you form an association between those two things. It could even just be different meanings of words in different languages. For instance, how the word cat is in English versus French. You form an association between those two things. And the reason why these associations are relevant is so then when you get presented with one of these elements individually, you can reproduce the other member of the pair. For instance, if I ask, what does the word cat mean in in Spanish, I can say gato, right? So I'm able to produce the other element of the association. And we refer to this, whichever element that is being used to trigger the memory of the other one, we refer to that as the cue. It's what produces the missing element. Associationism has a really long history. It goes, believe it or not, all the way back to Aristotle. It was continued by John Locke during the Enlightenment period. So a lot of early philosophers wrote about this. Believe it or not, so psychology as an empirical science is actually fairly young. It's maybe about 150 years old. So in the late 1800s was some of the first work in psychology, when psychology departments and textbooks were being created. But prior to that, a lot of philosophers actually thought about these issues and developed theories of it that they weren't able to actually test. So some of the first tests of these kinds of ideas happened in the late 1800s, early 1900s. Ivan Pavlov was one of the big scientists behind that, who won the Nobel Prize for some of his work on classical conditioning, which is basically the same idea. It's associationism, but specifically was observed in animals, and it was relations between environmental stimuli and physiological responses. But it was the same basic idea. It was all associationism. And many psychologists reproduce those findings in humans, even with associations between different words and so forth. So this has a very long history to it. Now, you might be wondering, well, then what's different about our current understanding? If people have been thinking about this for so long, ideally we've advanced beyond that point in some regard. Now, the answer I want to give actually is that a lot of our current theories are heavily rooted in associationism, but it's sort of like associationism on steroids. And the reason why is because what we now think is associations are essentially formed between everything you experience. Meaning that if I'm staring, like for instance, if I see my phone on my desk here, I don't just form an association between phone and desk. I form it also to the contents of my entire room, this monitor here, the chair here, my cat that's also in the room, the house itself, and even my mental state. Everything becomes a part of this association and memory, which is actually much more robust because you can use many more elements to retrieve your memories. And we refer to this because of this idea that you associate things to the entire context in which they're embedded in. We refer to these as kind of contextual binding theories. There are a lot of different theories. A lot of them are actually implemented as mathematical models that can be applied to data directly. But I'm not going to be talking as much about that side of things. I'm going to be talking about this at a much broader level. So just to give an example, let's say you are at a brunch cafe. Part of the reason why I chose this example, I think, is because that's something I'd really like to be doing right now during lockdown, is just to go out and enjoy brunch with some people. But let's say you're out at a brunch cafe. What becomes part of the memory? What is being learned here? Well, essentially, associations are being formed between the people, your company, essentially, the people that are at the scene, the food being served, and the physical location, the actual restaurant you're at. All of these things are being all associated together. But not just that. It's not just the physical surroundings, but even also what's going on inside your own head, your internal cognitive states. So this can be your mood. It can be what you're thinking about and what you're feeling. It could even potentially be your goals and other sorts of things. And these help organize the memory, and these also help you also serve as components you can use to retrieve the memories later. So the reason why this is consequential, as I mentioned, is that any of these aspects of an experience, any of these learned elements, can be used as cues to remember what was associated to them. So just as I mentioned earlier, if you associate A and B together, you can use A to produce B. But if you have A associated to B, C, D, E, F, and these are all associated together, that means you can potentially use any of those elements to reproduce or recall the other elements. Now, so in order to remember something, this is one thing that can be a little counterintuitive to people that haven't thought about how memory works. We're so good at remembering things, and remembering is so effortless that we don't sometimes have any sense of what the process involved is. But in order to remember something, you always have to have a cue present from the original event. This is what allows us to retrieve other aspects of the event that were associated to them, that were linked to them. Now, there's two caveats here, because one of the first things that you might be thinking is, well, wait a minute, but sometimes I don't remember things even if people produce these cues. Sometimes there can be cases where somebody can show a photo of you at an event, which is a pretty effective cue, and you still may fail to remember something. So what are the caveats here? Well, the two caveats are that cues that are associated with many events are going to be less effective. So things that are present across many, many different events across your life are in some ways can bring about too many memories. So this makes it harder to get back the particular memory you want. And then the other caveat is that the more cues you can present, the better. So, sometimes cues can be, an individual cue might be incomplete, but you can, the more cues you can present, oftentimes the better memory people will have of the original event. And I'm going to try to walk through an example that I hope can get across these points. So let's say, for instance, somebody were to ask a question like, do you remember what we did at our family Christmas from 20 years ago? Somebody were to ask me this question. Well, that's a question I'm just not going to be able to answer by its own. It was too long ago. So, but let's see what comes out of my memory. If I get this cue, family Christmas, well, the thing is, again, going back to this idea of ineffective cues, is the thing is too many memories, if anything, come back from this. For instance, like, well, it could be Christmas at home. We did that a few times. We did Christmas at our grandparents' house in Florida, Christmas at our other grandparents' house in Illinois. There was a Christmas ski trip in Colorado, etc. You know, there's a lot of different possibilities that could be coming up here, and this makes it actually difficult for me to state precisely what the answer to this question is. But if somebody were to give me an additional cue, such as, well, by the way, it was in Colorado. Well, now let's see what happens in response to this Colorado cue. So I get all the memories of Colorado that pop up into my memory. One was, there was a cross-country driving trip where I stopped in Colorado with a friend. I've been to Denver, visited Denver before. I've also been to Denver Airport many, many times. And there was this Christmas ski trip in Colorado, right? So when I take the intersection, essentially, between these two cues, it's really this particular memory that is uniquely identified by these two cues. And now, all of a sudden, this is what enables me to produce any memories. Oh, right. So yeah, Christmas in Colorado, we did a ski trip. It was in Breckenridge. We did about 2 or 3 days of driving to get there. Now I'm better equipped to get more things out of my memory by having two cues present for this. So just to elaborate on some of these principles, cues that are really uniquely associated to a single event often enable better memory for that event. They're tied to that event and to only that event. You know, for instance, if you go vacation once in a particular, like let's say you go to Bali or someplace like that, and you go there once, you can sometimes have very good memory for that trip. If you go every year, all of a sudden it becomes much more difficult to tell each of these events apart from each other. So I'm just to give a couple of examples of my own. One example I have, I remember when I was very young, there was a video store we went to when I was a kid. And it had a very unique kind of dusty smell to it. And I remember we visited years later. And I remember walking into that video store and I smelled that distinctive smell again. And I just had all these memories come flooding back of visiting this store. Smell is something that oftentimes produces these kinds of experiences, but what I want to emphasize here is it's not necessarily smell itself that's doing it, it's the fact that it's uniquely associated to a particular event. It's that distinctiveness that is what makes it effective for memory. If I had smelled that smell in a lot of other places, I wouldn't necessarily have that experience. Another case involving music that many people might have is something like an ice cream truck. Is the sound and music coming from an ice cream truck is very distinctive. It's uniquely associated with ice cream trucks. If you hear that music, that song, all in that twinkly sound, right? You just hear it and immediately your first thought is an ice cream truck, because that particular sound and music is uniquely associated with that experience, and that's what it reminds you of. If that was something you had heard across many different types of events, you wouldn't have that experience. So the opposite is also true, right? Which is that if cues that are associated with many, many events are much less effective. And so this is one of the sobering realities of this presentation about getting older, is even if your brain does not degrade, even if you don't have dementia, your memory is just going to get worse by virtue of having so many cues that become associated across many, many different events, such as, if you stay in the same house for a long time, the same place, the same job, having so many surroundings, common surroundings, makes it much more difficult to remember particular events or memories because they're shared across too many events. A classic example we're living through right now is poor memory in the times of COVID-19. This is something I could have called in advance, is that everybody would have really poor memory right now, because now all of a sudden everything's taking place in the same place. We're all at home now. You have work, you have entertainment and socializing all happening in the same place. It's so much easier to get conversations and events confused with each other by virtue of this. Even the way we socialize with people has become more homogenized now. For instance, we're constantly doing Zoom or video chat or things like that, and you don't have those unique things associated with conversations. You're much more likely to remember events with other people if they're in unique places. You have unique circumstances, music, sounds, other kinds of things around them to provide effective cues to help remember those events later. Now, anything can be an effective memory cue, as long as it's uniquely associated with those events. So coming back to the smell thing, many people have noticed that particular melodies or smells are very effective in producing memories. It's a common thing I always get asked, like, are these special for this? They might be special, they might be a little bit better, but the key thing I want to emphasize, what we know from memory theory, is it's really, again, always about things that are distinctive and unique to particular events that make things effective memory cues. So it may not be the melodies or smells themselves. It may be the fact that they're, again, uniquely associated with these memories. You know, certain things that people say, like, they're like, oh, well, you know, I had this, my grandmother used a particular perfume and I smelled it, you know, 30 years later, and I just became reminded of her. I had all these memories of her. Well, part of the reason why it may not necessarily be smell itself that is the thing, but the fact that perfumes tend to go through some stylistic revisions over the years, right? Which is that a perfume that may be popular in a particular decade may not be popular again for 30, 40 years, to the point where you smell this again, you know, and all of a sudden you're reminded of your grandmother. But it's not, again, not necessarily the smell itself. If you had smelled that perfume every day of your life, it wouldn't necessarily remind you of her at that point. Or it wouldn't provide as strong of a memory cue for that by virtue of that. So anything can be an effective memory cue, is what I really want to say. It can be a painting, it could be a visual, it could be a sound, it could be a smell. Anything, as long as it's uniquely associated with that particular event, it can produce this rush of memories. Can places be cues? The answer is yes. Even places themselves can serve as really strong memory cues. One of the common examples people give is returning to your childhood home. And if you go back to your childhood home, you may bring back a flood of memories from that time. Now, some people may not have that experience when they go back to their childhood home. And the question I want to ask any of them is whether or not they moved out before the end of childhood. So going back to what I was saying about cues have to be uniquely associated with that event to produce that kind of strong nostalgia-like experience. If you moved out before the end of the childhood, that is what is going to remind you the most strongly of that. It's uniquely associated with that time period. I don't have this experience when I go back to my childhood home because my parents still are living in the same house as when I was 7 years old. So it's associated with all kinds of memories for me. I don't get that rush of memories coming back when I go there. So now this has also been studied pretty extensively in the lab. There have been many, many studies, decades of studies, that have shown that you actually tend to have better memory for particular events if you revisit the locations in which those events were learned. I want to share with you a study that I thought did a very cool example of this. It was probably not an easy study to conduct. It was a study by Godin and Baddeley that used scuba divers. And in particular, the scuba divers who were the subjects in the study. What they did is they learned a list of words. So a lot of times our memory experiments, the way we test them is we have people learn a list of words that they can be tested on their memory for later, where they're asked, hey, what was on this list of words? And they have to recall them. Donald Trump gave an example of a word list recall experiment in the news about a month or so ago. So in this experiment, subjects learned words either underwater or on land. I mean, it's pretty crazy that they got people to do this underwater. And even crazier, they also had people tested on their memory underwater or on land. I'm still not sure how they exactly did the memory test, if they had to write words down or if they had to like recite them over some radio or something like that. But essentially what you have in this experiment is you have 4 total conditions. You have 2 conditions that comprise when people studied the words on land. They were either tested in the same location So I used this black arrow to indicate that it was the same location, or they were tested in a different location. So I'm using this gray arrow to denote that, meaning that they studied underwater, but came out of the water and were tested on land. And then we get the same thing if they studied on land. They either changed their circumstance for recall and had to recall the words underwater, or they had to stay on land and recall the words on land. And the interesting thing concerned the memory performance results. The highest performance occurred when people stayed in the same context. So if they were tested in the same place as they learned the information, they had the best overall memory. You might think in advance that people would just be worse if they were underwater, because that doesn't seem like a very good circumstance to be learning or information or to be tested on your memory. But it really, again, was about the match between contexts. And going back to this idea of contextual binding theory, it's this idea that the place around you is a part of the memory itself and serves as a cue for remembering aspects of that experience. Now, I'm focusing on physical location here, but as I mentioned before, that is not the only aspect of context. Context even applies to your psychological state. This is a part of the memory itself. These same findings have been reproduced with both moods and emotional states. If you learn information in a particular mood or emotional state, you'll actually have the best memory for that information if you're in the same mood or emotional state. And this can be applied a little more generally. For instance, when people are sad, they tend to remember more events from when they were sad. If people are happier, they tend to remember more events from when they were happy. It's one of the things that might make depression a little bit more difficult to treat. I'm not a clinical person, but yeah, a lot of times what has been observed with depressed people is they tend to tell a lot of sad stories. They tend to remember a lot of sad memories. And one of the things that makes it harder for them to break out of this is this memory bias. They tend to it's much easier for them to remember events from their life from when they were sad or more consistent with the state they're in. Whereas when you're happy, that's one of the things that can sometimes make you almost snap out of depression, is you're all of a sudden able to remember a lot of happy memories that are more consistent with your current circumstances and experiences. Now, there are also some novel predictions that emerge from this framework concerning learning across multiple contexts. So we all know that repetitions improve memory. You don't need a memory scientist like me to tell you this, right? You've all learned this from studying. You know, the more you study, the better your memory performance is. And the way we think that this operates is that repetitions essentially serve to strengthen the associative bonds between elements of an event. But a question that emerges, what is an ideal repetition schedule? Like if you have to distribute your study time across time, what's the best way to do it? For instance, if you needed to study for an exam or practice piano, is it better to study 7 hours on Sunday or 1 hour each day? Now, if you're to actually ask students or lay people, they almost always tell you that it's the former. People intuitively believe that it's better to mass all of your studying together. But it's actually the opposite. Many, many studies across decades of memory research have found that it's the latter, that it's better to actually spread out your studying over time. And this is actually something that contextual binding theory predicts. Now, I tried to illustrate this as best as I could. So bear with me for a second, but I anticipate there might be some questions about this. So as I want to mention earlier, the learned content that whatever you're experiencing is always associated to not just your physical environment, but your cognitive and emotional states. And these change over time. Like for instance, the way you feel on Monday is going to be a little different than the way you feel on Tuesday, which is going to be the way a bit different than the way you think and feel on Wednesday. And I used this change in your mental state. I illustrated this with different colors. And they change gradually such that, Monday is a little similar to Tuesday, but it's different than Friday, right? So I try to kind of illustrate it in that way. So think about it this way. If you practice piano 7 hours on Sunday, there will be a very strong association to this blue context, which will mean that you can do well if you're tested in a similar context. For instance, if you're tested in this purple context, this other blue context over here, you can still do well. But you may have very poor memory when you're tested in a different context, like this peach context down here, because you've associated to a very specific set of elements, and those may not be present in a future time where you're attempting to remember this information. But if you distribute your learning across time and practice 1 hour each day, even though you have weaker associations, you associate to a broader set of contexts. This better equips you in the future for the kinds of contextual states you might be experiencing, and enables you to have better memory in novel contexts, such that, for instance, you learn on this orange day over here. Well, there's some orangish, peachish days over here that it will prepare you for. The blue better prepares you for the blue over here. The purple kind of resembles this dark color over here, etc. So it better enables you get such a wider sampling of the set of contextual states. It better prepares you for future contextual states. This has, again, been a finding that has been so heavily replicated that spaced out learning over time is one of the main recommendations for classroom educators. This is a book here called Make It Stick that contained an entire set of recommendations for classroom educators from two leading memory scientists, Henry Roediger and Mark McDaniel. So spaced learning is one of those things. If you're constructing a classroom curriculum, it's much better to continually revisit content, because this makes your students, associate the content to a number of different contextual states. It better prepares them for future contextual states when they need this information. And again, this is, now I illustrated this at a course level, but there are actually formal mathematical models that can actually not only yield these predictions, but even make some predictions for when there can be certain exceptions to this pattern. Now, the entire time I've talked about psychology here. Now, a question that might be on your mind is, well, what about the brain? You're not really talking much about neuroscience here. Well, as it happens, so one of the things we know about the brain is there's a region in the center of the brain called the hippocampus that is critically involved in memory. If you remove the hippocampus, people are almost entirely unable to create new memories. So several movies have been made about this kind of phenomenon. And what the hippocampus basically does, if you look at the architecture of the brain, many areas in the brain are very specialized. There are areas like the occipital lobe, which is specialized for vision, the temporal lobe, which is specialized for hearing, etc. And there's areas for motor control and so forth. And one of the things that's interesting is all of these areas actually converge in the hippocampus. So the hippocampus is an area that essentially receives input from virtually everywhere in the brain. And so this is what enables it to carry out the kinds of associations described by contextual binding theories. This idea that you associate everything together. You associate, what you're hearing to what you're feeling, to what you're seeing, to your own mental states even. It's because essentially it receives projections from all over the brain. And there have actually been neural network models, artificial neural network models developed for the hippocampus that can illustrate memory in this way. For instance, if you present it with a partial pattern, only some of the input of what it initially experienced, it can reproduce the other aspects of that experience. So the hippocampus actually, in some ways, seems to be doing a lot of what we think contextual binding theory is about. It seems to converge pretty nicely on that. So just to wrap everything up, because I think I'm probably going a bit over time, the idea, again, what I want to emphasize here is whenever you experience something, you're always associating what you're learning to everything around it. All aspects of the experience are being tied together. And this is not just the physical stimuli, so things that you're seeing, you're hearing, you're touching, but even the location of your the location around you and your own cognitive state, what you're thinking and what you're feeling. And again, if we want to understand what it is you're remembering or forgetting, you remember events by being presented with learned cues from the event, from the episode itself. And you're most likely to remember events when these cues are uniquely associated with that event. And also, when that fails, when you can just have more cues. So the more cues you can present from the original event, the better your memory is going to be for that event. The more likely you are to trigger this rush of memories. Thank you very much for having me. Should I stop sharing or?
Yeah, stop sharing.
Yeah, sure.
But you're welcome to if any of the slides, I guess, are obviously relevant to any of the questions, and you want to re-emphasize it, just bring it back up. It's all good. Thank you so much for sharing that. I mean, it's quite amazing. I funnily enough, was just talking about a video store experience just the other day, and remembering something which was, if I remember. 25 years ago, potentially. So, quite some time ago. But I really loved both the, certainly that explanation of the piano playing in context. It was absolutely fantastic. So thank you. Look, Mackenzie Murphy has started putting some questions through. So I'll start by posing those ones, and I'll leap in with some of my own as well. But if anyone has any questions, please do put them in the Q&A function. These events, whilst an hour in length, actually disappear in absolutely no time. So we'll finish up by 1:30. So if you've got questions, put them out there. As they're being answered though, I'll put some of the links in the comments, as I mentioned I would, which will include your website, the conversation article, and also a reference to that Make It Stick book. I'll put a link to that book in there. So Adam, thank you again. So Mackenzie's asked, talking about smells associated with a particular event, can you comment on situations where you smell something and it's familiar, almost nostalgic to you, but you can't seem to pin down the memory it's associated with? So I guess something sparking, but you're not quite being able to place it.
Yeah, I mean, that can happen all the time. You can have this, not even just with a smell, I mean, in the same way that, we have this all the time with faces, right? Where you see someone that looks familiar, but you're unable to quite recall where you've seen them or what, what it's associated with. Yeah, and so that can happen with just about anything, is where you seem to know it. The actual, experience is partially familiar, but you're just unable to quite get all the way there. And what we think is going on there is this is probably another case where you just need an additional cue. That those, whatever bonds that are present between, for instance, the smell and the initial event just aren't quite strong enough. They're strong enough for it to be familiar, but not quite strong enough to retrieve or recall other aspects of the event. But that's another case where if you can just get an additional cue, you can oftentimes have a memory of this. And this is why, one of the common you guys may have had this experience yourself, where if you're just unable to remember something, stop trying and instead just continue the conversation, because you'll probably remember much later, because something else, another cue will arrive and you'll be like, oh, that's it, and you get that additional cue and that converges on the memory.
Fascinating. If you don't mind me asking, and sorry, I know you'd referenced elements, but how does I guess as an inhibitor to the cues, so stress, anxiety, maybe even situations like we're talking about, how not how much we should emphasize them, but how much of a factor are they in being able to recall cues? I'll ask quite simply.
Oh, excellent question. So this is a bit outside of my area of expertise, but there have been a lot of studies that show trauma and things like that do tend to impair memory. The thing that can come up, and this is what I don't know about, is that this can come about through many different ways. So one is that, going back to this idea of context dependence of memory, this means that if you're not feeling like that later, it's going to be a little more difficult to remember that event. Having, been through some dicey situations myself, the way they feel is so different than, like, if you're in danger. The way you feel is so different than the way you feel normally. It can sometimes be a little difficult to recall aspects of that event. The other thing is it changes what you attend to. So, for instance, there have been a lot of studies on in the eyewitness memory literature of when weapons are present at events. So that's a classic case where people actually have very poor memories. If somebody brandishes a gun, all of a sudden memory for the perpetrator goes way down. And the reason why is actually, people have conducted eye tracking studies on this, and the reason why is, where their eyes go when somebody holds a gun? Or they go right to the gun. That's what they're looking at. They're not looking at the faces. They're not looking at aspects of the perpetrator. People are watching the gun. And so then they'll actually have really good memory for the gun, but less so for other aspects of the experience. So the way I describe things in the talk is that you associate all aspects of the experience together, but you're gonna be most strongly learning the things that you're attending to very carefully. So things that you're not attending to as much or not focusing on as much is still going to be a part of the memory, but to a lesser degree.
Okay. Oh, look, thank you for that. That's fantastic. And I think the content struck a chord because we've got questions starting to fly in thick and fast. So look, well, I'm just going to keep plowing through them. It'll take us right up into the time, which is great. But let's get stuck into it. Mackenzie, I know you've asked another question. We'll come back to that. There's some correlation to something we'll mention a little later. Let's go into Ian's question. Ian's asked, where would you fit the concept of deja vu into this framework? Is that something you can comment on, that particular, not phenomenon, but concept?
Deja vu, that's an excellent question. This is, so this has been studied. It's difficult to study because it's such a rare event. So the way I would probably fit it into this framework, and we're not certain whether or not this is true, is that you could experience something that's highly familiar, but again, not being exactly sure of whether or not it's actually happened. Like, for instance, you could have deja vu moments where you're just meeting up with, anything. Like, I remember one time playing tennis once and I had this deja vu moment. And it's probably just that you have a lot of aspects of the experience that are highly familiar to the point where you really start being like, wait a minute, have I already actually lived through this moment? And so, your memory system is having just a hard time trying to figure out what exactly is going on. That's the best guess I can give, but people aren't exactly sure. Some people think it might be some kind of weird neural glitch where just this, something kind of pops off and says, this is highly, familiar, but what you're experiencing actually isn't. So it's almost like this weird glitch that you experience. Not quite a glitch in the Matrix, but, similar to that idea.
Still a fascinating topic of conversation and will persist to be for many years to come, I'd say. Yeah. Joel's chimed in. Hey, Joel, would it work to force place and smell cues while learning to then use these for recall later? So I guess influencing the recall cues.
Oh, sorry. What about? Okay, sorry.
So the question was, would it work to force place and smell cues while learning to then use them for recall later?
Yeah, I mean, certainly the better able you are to manipulate or record some of these cues, the better. So, for instance, if there are, even, like this is why commonly, mementos from a trip can also, be very effective cues. Like if you buy souvenirs when you go on vacation somewhere, part of the reason why that works so well is, again, this is a cue from the original event that you can use to retrieve other cues, which can also snowball from there. You can retrieve aspects of the memory, which can retrieve other things. You can kind of chain along in that respect. So yeah, certainly, like photographs and mementos. A lot of these things are things that people actually already do. It's kind of funny how people, in some ways, already have some understanding, even though they may not have made the explicit connections. People already, as users of memory, understand what will, better enable them to remember events later. So,
have you encountered many, particular actions of people that you've encountered that do something on the regular that you either find surprising or see that is quite effective? I've certainly met a few people along the way that would say, for instance, make sure they say someone's name multiple times when they first encounter them, over and over, almost not annoyingly so, but you can literally see what they're doing. They're just saying it, so it just seeps into their brain. So, I mean, that type of example, but other examples, have you encountered many of those?
I mean, that's an excellent example. Repetition is one of those simple things that help memory. And so, yeah, absolutely. If you're bad at remembering names, try things like that. I find everybody's bad at remembering names. It's really the only people that seem to remember names well, I don't think they have some innate name memory. They oftentimes actually tend to attend to those names. They tend to repeat them. They make an effort to remember those things. So an effort goes a long way. Telling stories is another example. Like, for instance, at the end of your day, if you tell stories about things that you're trying to remember, whether it's the events of your day, whether it's a book you're reading about, or something like that, you'll have better memory. Things like book clubs will give you better memory for the books you've read because you have a group discussion. Going to movies with a friend, having discussions afterward.
Yeah.
All these things, are pretty effective in producing memories. Diaries, it can be cumbersome to spend the time each day to record the events of it, but just the act of writing it down, not even necessarily reading it later, will produce better memory for those events.
Yeah. Okay, great. Well, thank you. Thanks. Jeanette's chimed in when you talk about the sameness of experience and the current conditions where we're all in the same place, nonetheless being in confined circumstances, actually attunes you to differences within that context. So this suggests that the more sensitive we are to the uniqueness of all experience, the more able we will be to remember. Do you have thoughts or feelings on this one?
Yeah, I certainly think if there are ways you can focus on unique aspects of your experience on each day, you can overcome certain aspects of the limitations. I think my suspicion is that it only goes so far. Memory, as I mentioned, is kind of multimodal in the sense that all of your senses are really a part of it, and that's one of the things that can produce very rich memories. So that's why there's nothing will compare to being in physically different places where you have just so many unique experiences. When you travel to another country, you have so many things, unique smells, sights, foods, so many things that will make you, if let's say you go to Greece and you never go again for 10 years and you go back, you'll have an experience that you won't be able to have on the regular, because just so many things that you hadn't experienced in those 10 years will familiar and bring you back to that trip you had before.
Yeah, amazing. Oof, travel. Wouldn't that?
Yeah, I know.
Wouldn't that be nice at this time?
I'm teasing everybody with these examples of going out to brunch and traveling and all these things. I apologize for that.
Certainly. Yeah. No, it's good. It's memories past. Would you, Tegan's asked the question, would you be able to comment on severely deficient autobiographical memory? So what is its status in the academic world? So I guess where is that at from a research perspective? Is there a point in the memory process that is abnormal for people with poor autobiographical memory?
That's a really good question. To be honest, that is something that is a little outside of my domain of experience. It could be certainly some brain deficiencies. I'm not sure. The weird thing that makes it a little difficult to comment on is like autobiographical memory does seem to be a little bit of a different thing than the kind of memory we study in the lab. People with superior autobiographical memory that can remember everything for their lives, sometimes they get a list of words and they're just okay at it. So they seem to be just doing something a little different than what we know normally. Just speculating off the cuff, one of the things I've learned about memory is how much, how little we appreciate how our circumstances contribute to our memory. So going back to, how COVID-19 has produced a certain homogeneity to our experiences that gives us really poor memory. Going off the cuff here, but it's possible that sometimes when people have very poor autobiographical memory, it could be due to the nature of their own circumstances, due to the structure of their lives or other kinds of things that makes it just less able to remember certain events. An example I might give is like, let's say if we were all physically in a room together and Tom Cruise walked in the room, opened the door, walked in and said, "Oh, geez, wrong room, sorry," and walked out. We'll all we might all remember that event for the rest of our lives, right? Highly distinctive event. Whereas, will Tom Cruise remember seeing all of us for the rest of his life? Probably not, right? That's not a very distinctive event for him. And so, in comparing, our different memory for this event, the conclusion is not, therefore, Tom Cruise just has a poor memory. It has to do with the structure of his experiences versus the structure of ours, and how unique that event was for each of us. So I don't know if this is quite the answer to the question, but the reason why I'm saying it is I think we often do not always appreciate how the differences between our experiences contribute to our ability to remember them.
Yeah, no, that was a great explanation. Thank you. Even if it's not quite embedded in your particular research, we do appreciate you, drawing some alignment with some elements of what you do research and put out there. Before I go into the last questions, I do want to lean on what you do day to day. So you are obviously a senior lecturer within the School of Psych Sciences, but let's talk a little bit about your role within the Melbourne Computational Memory Lab and the Complex Human Data Hub. How is that an extension of your communication of the research, both to students and into faculty across the university landscape and more? So with reference to those two labs or hubs?
Yep. So I run the Melbourne the Computational Memory Lab, and so I currently supervise like 3 PhD students and 4 honor students that conduct a lot of experiments that are kind of similar to the ones I described, where we give people lists of words to recall or recognize, but also do a lot of computational modeling on this data. Now, when I say computational modeling, it's the kind of thing people don't always associate with psychology. Basically, what we take is we take aspects of theories, like, for instance, contextual binding theory, and we actually make a mathematical model that can be simulated and can derive predictions about our experiments, the manipulations we conduct, and what things will produce better memory or worse memory. And we're able to apply these models directly to the data we get, and this can serve various purposes. So one is that you can better understand what manipulations of memory do. What does it impair exactly? Does this impair, contextual associations? Does it impair the ability to retrieve those associations? That sort of thing. But it also enables you to better understand different populations. So you can, for instance, potentially, I haven't done this myself, you can use these models to understand differences between populations. So you can basically say, if one group is performing poorer in memory than another, what's different about them? What's different about, is it about the binding process? Is it about the retrieval process? That sort of thing. You can use this to deconstruct performance into these kinds of psychologically meaningful variables. So that's kind of what we do in my lab. I'm a part of the Complex Human Data Hub as well, which is a set of, essentially a whole set of labs that we all do computational modeling work of some kind or another. That relates to human data in some ways. So some people do this. I happen to be a memory expert, but sometimes some people do this in the domain of categorization or language or decision-making, vision, various topics that we all address, where we basically try to get our answers using computational techniques.
Awesome. Yeah, amazing. Look, I can't wait to see what that's like when I guess that physical convergence within Melbourne Connect when that happens. But yeah, absolutely incredible. And obviously this a highly digital technology focused precinct, so it'll be incredible with that psychological aspect placed over it. Look, as I promised, we're getting truly towards the end. So let's dive into Melissa's question. Are we able to retrieve memories of dreams we've had but do not remember upon awakening? So is this progressing, or are there particular techniques in order to be able to remember dreams more effectively?
Oh, that's a great question. Another one I wish I could answer, but dream research is really difficult to conduct because of, it's hard to reproduce dreams in a lab. But people have conducted studies on them, and typically the best memory you're going to have for the dreams is when you just wake up, when it's really fresh, and it seems to just fade really, really rapidly. So so you tend to have memories instantly, and then they kind of go away. The best way to remember dreams is to either write them down or tell them immediately. So, that's usually the kinds of dreams where people talk about, oh, I had this dream once. It's usually because they thought about it a lot when they woke up.
Sure.
And we're able to kind of reflect on that. The reason why I think, dreams are really poorly remembered is going back to the idea of, context and there being context shifts. The experience of being in a dream is so radically different than your awake state that it's almost incompatible and you're unable to retrieve those memories. And so I think part of the reason why when you just wake up, you're kind of in an in-between state. So you still have partial access to that information, but by the time you transition, you're almost unable to remember these things. This just seems to be, a common aspect of our experiences. When you have a radically different shift in your experience, it's, this is part of why you cognitively transform so radically, I think, is because of, your ability to remember things and reconstruct a narrative just also so completely shifts. You're only able to remember things that are consistent with, or you're mostly able to remember things that are consistent with your current experience.
Yeah. Okay. Well, thank you for that. And again, I know we're diving into things that sit outside your prime body of research, but yeah, we really appreciate you drawing the alignment between them. As we get towards the end, so Mackenzie's asked, have you done any neuroimaging research, such as EEGs, to monitor the memory processes that occur whilst people are being given cues to retrieve a memory?
I have not personally done this, but I am aware of a lot of work that is being done on this. One of the things that is an exciting direction is linking some of this work with computational modeling. So this is a very new area that I plan to get involved in, because one of the things that has been difficult, so neuroimaging has been happening for a while, where it has probably not led to as much progress as people hoped, is that we don't necessarily always understand what's being recorded. So, genetics sometimes has a similar problem where we can measure these things, reasonably well, but we don't understand what it means. And so this is where computational modeling, can actually serve as a really unique intermediary, is by applying computational models in conjunction with brain data, is now we can actually link some of the brain data to the cognitive states from our computational models. So this is something that some people, it's not happening as much in memory, but in other areas, people are doing quite a bit of work on this, and enables us to better understand some of the neural processes that are being recorded.
Okay, cool. Look, thank you for that explanation. I'll ask you a really quick one. So what's some, upcoming research that you're involved in, both what you're involved in at the moment, but I guess potentially next on the horizon?
Yeah, so one of the things I'm trying to better understand is how one of the things we still have a really poor sense of from our current laboratory experiments is, so one of the things I've been emphasizing through this talk is how the structure of people's experiences has a huge role in the memories, what's able to be remembered. One of the big problems we have as an empirical science when it comes to human memory is we don't understand people's learning history when they come into the lab. So that's a huge black box for us that we don't understand. And so myself and others have argued that this is really critical, but we don't have a good way of measuring this. So we're trying to, through the Complex Human Data Hub, some of my colleagues and I are trying to better understand people's learning histories using other forms of technology, especially with smartphones and things like this. We can get a better understanding of what people's environments are, what people's experiences are in advance of a learning episode. And so that way we can start to understand, why is one person really well able to remember something and somebody else isn't? Well, it might just be due to the different structure of their experiences and environments. So this is something that is going to be a very emerging, a highly emerging topic of research that is uniquely offered by newer technologies. So.
Oh, amazing. Oh, look, I really appreciate you explaining that. Thank you so much. I'm really stoked to have had you involved today, and loved the presentation and loved the many concepts. Obviously, people were have many questions about it, and apologies if we haven't asked them all, but we do appreciate the broad series of questions. It's a fascinating topic. We're going to dive into more concepts of memory throughout the Understanding 2020 program, which would be great, and obviously further emphasize Complex Human Data Hub upcoming research streams. So Look, Adam, thank you once again for being here. People can find you on Twitter at Adam Os. Sorry, I'll spell it ADAMOSTH. And also the school, which is at Psych Uni Melb. If anyone wanted to find out further details, publications and links and so on. You can find Melbourne Connect at Melbourne Connect, and we'll be running an event next Tuesday focused on innovation precincts as part of the Digital Innovation Festival. So feel free to join us. All our events are published via our website, melbourneconnect.com.au, and also the Facebook page event stream. Adam, thanks once again. Have a fantastic day. Look after your cats, and we'll catch up really soon.
Yeah. Thanks so much for having me. It's been a blast.
Yeah, and we'll publish this out on YouTube afterwards as well. I'll get the recording all ready and put that out there for everyone's consumption.
Cool. Thanks so much.
Have a great day, Adam. Bye all.
Bye, everyone.